Hello, everybody. This is Emhyr Subramanian, and you're watching a crash course on mass points. So, mass points is a certain geometric tool, a tool in geometry that you can use to simplify proofs and to, more importantly, what we're going to talk about, to simplify how to find ratios. So this is just an introduction problem. So what mass points involves is to assign weights to different points and accordingly find out ratios. So in this diagram right here, we have a triangle A, B, and C. It doesn't have to be isosceles or equilateral, but all three of the medians have been drawn. And if you don't know what a median is, it's basically a segment in a triangle that divides the other intersecting segment into two congruent parts. So, for example, this is congruent to this, and this is congruent to this, and this is congruent to this. So that's what medians are, and the properties of a median is that if you draw all three medians of a triangle, they intersect at a certain point. So now let's label some points. Alright, so let's call this point here D, then we'll call this point here E, and then we'll call this point here F. And then we'll call this intersection point G. Okay, so the problem that we're trying to find is what's the ratio between one of the shorter segments of the median and the longer segment of the median. So this is a shorter segment and this is a longer segment. Okay, so how you can start off is, so this is how to demonstrate mass points. So what you can do is first you can just identify some ratios here, since that's what you're trying to find, a ratio at the end. And a ratio is simply a fraction. So we're just trying to find, in this case, GE over GA, or DG over CG, or is that FG over BG. Okay, so what we can do is, we know that this is a 1. Oh, I'll do that in a different color. Okay, so this is a 1-to-1 ratio because we know that these are congruent. This is also a 1-to-1 ratio, and this is a 1-to-1 ratio. So now what we can do is we can solve. How you do that is you assign different weights. So let's take BC for example. So if this is a 1-to-1, then you can assign the weight of C to be 1 because it corresponds to this side, and the weight of this side, CE, corresponds to B, and that weight is also 1 in this case. So you can picture it as, let's say it's a scale, and there's the fulcrum, and as you add more things on this side's gonna go up, right? And so that's basically what this is right now. And in this case, it's a balanced weight system. So as you add more things to this side gets changed. As you add more things to this side gets changed. So that's how you assign weights. So this is the fulcrum, and in this segment BC, E is the fulcrum. So you simply add the weights, so you get that this is a 2. Alright, next let's look at AB. So AB, we already know B is a weight of 1. So in this case, A is also a weight of 1. Now let's say B was not a weight of 1, let's say it was weight of 2, then A would have to be a weight of 2 since they go by factors. So we know that D is also a weight of 2 because you add 1 and 1. And then lastly here, we already know the weights of A and C, so we can find the weight of F, which is 2. So if you don't understand any of it so far, feel free to pause the video and rewind. But just remember that it's basically this scale right here. and as you add more weight to one side, the other side gets changed. So now that we have all these weights, so what can we do with these? We simply need to find the ratio between the short to the long. So let's take E is 2, A is 1. We know that G has to be weight of 3 when looking at this segment right here. In this case, G is 3 no matter which way you go. But just you have to remember, for any mass points problem, you need to remember that G might not always be 3. Like if B was 2 and F was 4, then G would be 6. It just so happens that in all three cases G is 3. So you just have to remember which segment you're looking at and which weight you're putting. So now we need to find the length, the ratio between GE and GA. And so how you do that is, since you know that the weight of E is 2, AG must also be 2. So in case you don't understand why, it's just looking at this. BE corresponds to C, CE corresponds to B. In this case, point E corresponds to AG, and point A corresponds to GE. Alright, so since A, the weight is 1, since A corresponds to GE, that weight is also 1, right? So these are just ratios. So now you know that the ratio between GE and AG is 1 to 2, right? But this is the factor. So if you were asked what is the ratio between these two, it's a 1 to 3 ratio. And the reason why you say it's a 1/3 ratio is because GE is 1/3 of the whole segment, AG is 2/3 of the whole segment. Alright, so if you have any questions, just feel free to write it down in the comments below. Otherwise, I hope you understood and I hope you enjoyed this video. Thanks for watching. See you later. Bye.